G'day ladies and gents, this is Kai for Taught Through Gaming. Today we're going to be looking at the Ballistic Trajectory, which is a special trajectory that systems can move in. So first, what is a ballistic trajectory? It is the type of parabolic trajectory that is characterized by a homogeneous acceleration. In this case, homogeneous simply means that the acceleration is constant. Acceleration is constant when external forces acting on an object are constant. This means gravity is usually the only force producing an acceleration in these trajectories. So, what does a parabolic trajectory look like? Cool, right? It looks very clean, and it thankfully is also very simple to understand. Let's analyze this per dimension. We can see that in the z direction, the ball goes up, and then down. Now when we look at this from the top, we can see that there is linear movement in the x direction, and no movement at all in the y direction. Now let's look at some graphs to get a better understanding of what's actually going on. Looking at the graph for the movement in the y direction, we can tell that not much is going on. Looking at the graph for the movement in the x direction, we can tell that the movement is linear. This makes sense since the only force acting on the ball is gravity, which acts purely in the z direction. With no acceleration in the x direction, the velocity is constant, and so the movement graph is what is shown on the screen. Now, looking at the graph for the movement in the z direction, we can see that the movement is parabolic. If we differentiate the graph, we end up with the velocity graph. If we differentiate the graph again, we get the acceleration graph. This graph shows that the ball is undergoing a constant negative acceleration in the z direction, which is as we expected. Having a graphical understanding of this motion is good, but there are some equations that are required in order to understand exactly what is going on here. I won't go into how these equations work or how they are derived. However, I can say that these equations will only be used when we only have one unknown, whether that be initial velocity, final position, time, or whatever else it may be. These equations can also be used in conjunction with other equations, like the equations of equilibrium from free body diagrams, or equations of energy from energy analyses. That's all for ballistic motion. Thank you for your attention. I hope you learned something.